So finishing up section 3, once again talking about the derivative of a function. We defined the derivative as being the limit of the difference quotient. So really the only new piece here is looking at this new notation, f prime of x. Okay, so that's how we represent the derivative of a function f. If the function was g of x, it would be g prime of x. Okay, so it's really that little prime there that indicates we're talking about the derivative of the original function. Okay. So the derivative of f of x. So the derivative of f of x is equal to the limit as h approaches 0. That's important. You have to start putting that in front of your expressions. A lot of you are leaving that off. Of f of x plus h, which would be 3 times x plus h squared minus 2 times x plus h. That's just the f of x plus h, okay? And then I'm going to subtract the f of x, the 3x squared minus 2x, okay? So all of that is just the f of x plus h minus f of x, all divided by h. So from here, it's just a bunch of algebra, a bunch of simplifying. So let's see, we'll have 3, that would be x squared, plus 2xh plus h squared, that's our binomial squared pattern, minus 2x minus 2h, and then distributing the negative, I'd have a minus 3x squared and a plus 2x, all divided by h. Okay. Well, I got a minus 2x and plus 2x, might as well get rid of those now. Don't have to carry them along that way. So the limit, as h approaches 0, distribute my 3x squared plus 6xh plus 3h squared. Then I have minus 2h and minus 3x squared, all divided by h. So 3x squared minus 3x squared, they're done. And if I look at the rest of the terms that remain in the numerator, notice that they all have a factor of h. So I'll factor out the h, 6x plus 3h minus 2, all divided by h. Those h's will now divide out. I have the limit as h approaches 0 of 6x plus 3h minus 2. Okay. So if h is approaching 0, then what I'm left with is that the derivative of f of x, derivative of f of x as h goes to 0 is 6x minus 2. There is my derivative. And remember what this limit of this difference quotient does, what this derivative does, is it lets us find slope at any point on the graph. Okay. And to do that, I simply would need the x value, plug the x value into this derivative function, and that tells me the slope at that particular point. Another example. So derivative f prime of x, derivative of f equals the limit as h approaches 0, 4 minus 3 times x plus h squared. So there's my f of x plus h, minus 4 minus 3x squared. There's my f of x, all divided by h. So limit as h approaches 0. Again, it's important that we keep that carried along. 4 minus 3 times x squared plus 2xh plus h squared minus 4 and plus 3x squared. All divided by h. So continue simplifying. The limit as h approaches 0, 4 minus 3x squared minus 6xh minus 3h squared minus 4 plus 3x squared divided by 8. So we get some terms that are going to zero out. The 4 and the minus 4, negative 3x squared, positive 3x squared. And what I'm left with is the limit as h approaches 0. Notice everything that's left has an h in it, so I'm going to factor out the h. That leaves negative 6x and minus 3h divided by h. So now the h's divide out. Limit as h approaches 0 of negative 6x minus 3h. Okay. So as my h is going to 0, I'm left with the derivative of f being equal to negative 6x. Okay. So there's my derivative, which will allow me to find the slope of the curve at any point by simply plugging in the x-coordinate. All right. These are all just some other notations that are used to represent derivative. dy over dx, the derivative of y with respect to x, y prime. Sometimes we write functions as y equals instead of f of x equals. d dx of f of x, again, the derivative of f of x with respect to x. And this capital D with a subscript of x of y, the derivative with respect to x of some function y. So all of those mean the same thing as this f prime of x. They are all just a derivative notation. Okay, different notations depending on the context of the problem, or sometimes just depending on the mathematician or the textbook that you're referring to. Okay, but they all have the same meaning. Okay, f of x is square root of x. We want to find f prime, or the derivative of f. Okay, so derivative of f of x is the limit as h approaches 0, square root of x plus h minus square root of x divided by h. Okay. Well, as we saw before, when we have these radicals, we have to rationalize. We can't leave it in that form. So square root of x plus h plus square root of x, square root of x plus h plus square root of x. Okay. And start to simplify. So limit as h approaches 0. Remember, the numerator is just the conjugates, that a squared minus b squared pattern, a minus b, a plus b. So it's going to be x plus h minus x. That's the a squared minus the b squared divided by h times, I'm just going to leave this as a product of the factors. Because what do we see happens? Well, the x's zero out. Okay, I have h divided by h, which leaves me with 1. So I'm really left with the limit as h approaches 0 of 1 divided by square root of x plus h plus square root of x. So the derivative of f of x is going to be, as h goes to 0, I'm going to have 1 over 2 square root of x. Okay. And we talked, we said before, well, we don't want to leave radicals in the denominator. Okay, we could take it out of there, but it's really not going to make any difference at this point because we're just going to be evaluating that for some value of x. Okay, so here is our derivative of the function f of x equals square root of x. Okay, so at the point 2, 3, so the slope is 4, the point is 2, 3. So I'm just basically writing the equation of a line with a slope of 4 and containing the point 2, 3. So that's simply going to the point slope formula. So the point slope is y minus 3 equals 4 times x minus 2. Okay. So y minus 3 equals 4x minus 8, and y would equal to 4x minus 5. Okay, that is the equation of the tangent line at the point 2, 3. Okay, so using the derivative to find the slope, allowing us to write the equation of a line. So kind of pulling all these things from algebra and calculus and kind of showing that they're all really related. Okay. So, some more work with these derivatives in class tomorrow, and we're getting close to the end. Just a few things left to cover. So we'll see you then.